Today we are going to look at a new type of graph. Today we're going to look at how data can be displayed in box plots. Make sure you have your notes page so you can fill in all the important information as we go through this video. Take a look at this graph on the page. This is called a box plot. Right here above the number line, this is called a box plot for a couple reasons. One, you can tell that there is definitely a box in it, and it has some different values plotted along the way. If you look at the two line segments that extend out from the box, these are called whiskers. Now, two things I want you to think about, and then later on in the video, we're going to answer these questions. But start thinking on your own. Question number one, what do you think the dots at the end of the whiskers represent? So this dot at the end of the whisker, this dot at the end of the whisker. What do you think those dots represent for the whole entire graph? Then question number two, what do you think the dot in the center represents? So this little dot right here in the middle of the box, what do you think that could represent for all the numbers in this graph? Later on, we're going to answer these two questions. So think about that and check later and see if you had the right answer. What in the world is a box plot? A box plot is a great way to show or display a large group of numbers and show how they are spread out. There's also 5 key values that you can see when you look at a box plot. The first value you'll be able to identify is the minimum or the lowest value. So if you were saying on the previous page what one of those dots at the end of the whisker represented was the lowest value, you would have been correct. If we go all the way to the other end of the graph, the last dot represents the maximum value or the highest number in the whole entire set. The next plot or spot we're going to look at is right here in the center. Let me push back onto my pen. The little spot in the middle, that is called the median. And if you guys remember from elementary school, median actually means the middle. So this is going to be the middle number in the whole entire set. So you might want to add that to your notes. That spot is called the middle or the median. I'm going to go back and put a dot at the beginning and make this one say the lowest. I'm going to put a dot on this one and say highest. Highest number, lowest number. I know you guys want to say hashtag, but before it was a hashtag, it was called the number sign. Then we also said there were 2 other spots. So right where the box starts on the left, this is called Q1, or it's where the lower quartile is. I know that may be a new name for you, lower quartile, but that is what this part of the box represents. The other end of the box would be your 5th number that you can find out, and it is called Q3, or sometimes it's referred to as the upper quartile. Another thing that you might need to know, each one of these sections, if I were to make it into a whole, this is divided up into 4 equal parts. And if we divide a whole thing into 4 equal parts, that means each part is actually worth 25%. So that also tells you that in the center, those values make up 50%. If you look about this box right here, 25 plus 25, half of all the data is right there in the middle in those two spots. So we brought the picture back, a generic box plot, and we're going to point something else out. The other thing you need to know about the box, at the bottom of this page it says the box that's created by connecting Q1 to Q2 to Q3, it allows you to see the spread of the data. So I'm going to say if I start right here and go down to Q3, this is called the spread. This distance is also called IQR, or inner quartile range. So if you notice, this box is on the inner part. The whiskers are on the outside part. So if I want to know how much distance is this box taking up, it says I am going to take the Q3 value and subtract the Q1 value, and that tells me what is the spread of the data. And we're going to look at how to do that as well. Okay? Please make sure you write that down in your notes, because IQR, or interquartile, or especially it's referred to in story problems as the spread of the data, you definitely need to be familiar with that. The next thing we're going to talk about is, why do some box plots have really short boxes? Why do some box plots have part really long? Or what could it also mean when some boxes look the exact same size as one another? At the top of this screen, you can see kind of a definition of what they might be. If the one box is longer than another, it means there's more variation in the numbers. And basically, that just means that the numbers are very different. If a box is shorter than another box, then it means that those numbers are very similar. So if you take a look at this first one, everything is pretty close together. The box itself, they're both pretty small. They are not very spread out. So I would say that the values are, my pen's not writing good. The values are very similar. Okay? When you look at the next one, the blue one that says City A, if you take a look at this one, the first box is pretty small. But then the second box, very long. Okay? The little box that's in red that you see right here, this was actually called the lower quartile. I don't know if you remember that from the previous slides. This box is called the lower quartile, and then this box is called the upper quartile. These two boxes are not the same size, as you can tell when I traced underneath them. So if I wanted to say something about these two, I could say that if I had to compare these two boxes, the lower quartile and the upper quartile, you can tell that the upper one is much longer. When we look back up at the sentence above, it says longer. If the boxes are longer, it means the data has more variation or the numbers are very different from each other. So the pieces of data that fall into this upper quartile box, they have more variation. They are more spread out. So I'm just going to put down that for this one, the upper quartile has more variation than the lower quartile. And if I wrote that too fast for you, make sure and press pause so that you can write that down. because you're going to have questions similar to these types of things on your homework. There's one more to look at, the very bottom one in green that says City B. One thing we want to look at is the boxes, the lower quartile and the upper quartile. These are pretty much the same size. So we could definitely say that the boxes are very similar. So the upper and lower quartile have similar values. But what do you notice about this last box plot? Something is different from all of the other ones. I'm thinking this giant long whisker that goes out to the end to where the greatest value was, the maximum point. The distance that this is from where the upper quartile is, this creates an outlier. When you have a really long whisker, and it can be a whisker that's going down to the lower section too. This one just happens to be going to the maximum value. When you have a super long line sticking out, a line segment sticking out, that gives you a clue that that one value is way, way, way different from all the other numbers in the set of data. So I'm going to put that this one is a very high outlier because it's on the right. And this is a number much greater than the rest. And if the line happened to be going to the other direction, if it happened to be really long this way, I would say that the number was much less than all the others. But if it's on the right, your high outlier is a very high number. And the word outlier is also really important to know about your data. Now we're going to actually look at a box plot and use the numbers to get some actual answers. So when we're looking at this first question, the title of the number line tells us what content we're dealing with. This says test grades for Math 7. Also look at this graph. It does not start with 0. It can count by whatever you need to, and it can start with whatever number you need it to start with. It can end with whatever number you need to end with, as long as it can include all the values in your data set. The first question we're going to look at says, what is the median test grade? Now, I already remember that this one was the lowest score, and this one was the highest score. So median, does anybody remember what median meant? If you said that median meant the middle, then you would be correct. So the value that is in the middle, this is the dot that's in the middle. So if I go straight down from that one, see if I can draw a straight line. Looks like it's just barely past 80. So I'm going to say probably this number is going to be an 81, maybe an 82. Okay, it's kind of hard to tell because they counted by fives. So the median test grade is 81 or 82. The next question says, what does the median tell you about all the test grades? Well, we just got through saying that median tells us where the very middle is. So if I know the middle is right here at 81 or 82, that means half of the class got less than 81 and half of the class got greater than 81. One answer that you might write down is that half of the test scores are below 81 and half are above. That's one person's opinion of what the median can tell you. It definitely tells you the middle score of everything. So that can always be an answer that you put down for what does median tell you. But a really good thing to say is that half, it tells you the halfway point, or it tells you that half of the things are below and the other half are above. It's always the very center. All right, we got 4 more questions to look at about this same graph. I'm going to go back and fill in that we said the middle number was, if I can write on this, 81, maybe 82. So the next one wants us to figure out what is the lowest test grade. The lowest test grade is going to be this one that we said is on the very end. If I draw a straight line coming down from it, that one matches up pretty perfectly with 60. So I'm going to say the lowest grade in the class was a 60. The next question on the list says, what is the highest test grade? The highest score should be the one on the far right. Draw a straight line coming down from it. Holy moly, somebody made 100. The highest test grade was 100. Whoop, whoop. Next thing we need to find, what is the range of the test grades? Does anybody remember, what does range want you to find? The range of the whole data. Hopefully you remember it means take the lowest and the highest and subtract them. Okay, the lowest and the highest and subtract them. So that means I should do 100 minus 60. So the range of all the test grades is 40. From the lowest person to the highest person, we have a 40-point variation. Last question wants to know, what is the spread? We had this earlier. It was also called the inner quartile range. Inner meaning the inside, the inner part of the graph. And I want to know, what's the distance between these two spots? Okay. Another way we said to think about this is we are going to take Q1 and Q3 and we are going to subtract. So Q1, this looks like it's pretty close between 70 and 75. So I'm going to go with 72. If you want to say 73, that's fine. But then the Q3 perfectly lines up with 90. So I'm going to go ahead and fill that in as 90. If I subtract these, 90 minus 72, that should be 18, but let's double check it. 90 minus 72. Got 18. Okay. The inner quartile range, or the spread of the data, is 18 points. We also now can see that we have labeled those 5 key values. I got my lowest point. I got my highest point. I've got the median in the middle. I've got Q1, or the lower quartile. I've got Q3, or the upper quartile. So if you need to label those, feel free to do so. It's on the beginning part of your notes as well. Oh no! Help! Help! We need to be saved from the deadly box plot villains! Never fear. Spider Girl is here to save the day. Answer the following questions on your homework to advance to the next level and save Sanger from these masked villains.